This video is to help you with section 2.2.1 on composing integers. Remember, integers are whole numbers that are both positive and negative and also include 0. So the idea today is that we're going to develop an understanding of how to compose and decompose numbers in multiple ways. So for 231, it says Cecil is an acrobat in a local circus. His job is to move across a tightrope from point A to point B while blindfolded. He can only move using the distances you tell him to move in your instructions. He needs to reach the end of the tightrope, point B, to take his bow and go down the ladder. Assume the platforms on both sides of the tightrope extend infinitely, meaning having no end. Cecil may go past the ladder, however, if he does, make sure he turns around and goes back towards the ladder. So for the first one, what they want you to do is to find different combinations of lengths that will allow Cecil to go from point A to point B using only the given lengths. So for example, starting with A, they want the tightrope length to be 24 feet. You can only use lengths of 2, 4, 8, or 10, although you can use positive or negative, because positive would have him going towards the right and negative would have him going towards the left. And you want to get to exactly 24 feet. Also keep in mind that they're going to want you to come up with at least 3 different ways. So 3 different ways would be fine. There is a digital version of this activity on your ebook. So if you go to your ebook, section 2.2.1, you click on the Acrobat number line, it will show you a digital version, which may prove to be helpful. So I will simply go through a couple of these examples with you. As you look at part A, you'd probably think that's fairly easy. I'm going to use those lengths. It shouldn't be too difficult to get to a length of 24 feet. You could do something as simple as 10 plus 10 plus 4, because you don't have to use all of the lengths, all right? Or 8 plus 8 plus 8, or 8 plus 10 plus 10 plus negative 4, all right? So if you go forward 8 and then forward another 10 from there, you'd be at 18. If you go forward another 10 from there, you'd be at 28. But since we want him to only go 24 feet before he's going to go and take his bow and go down the ladder, we would have to add a negative 4. So again, when they give you these lengths, you can use positive or negative. So 8 plus 10 would put him at 18, plus another 10 would put him at 28, plus a negative 4 would put him at 24, which is what we want. All right. Some of these, however, as you progress, get more difficult. And this is something they will ask you to do on quiz and test as well. To be given specific lengths and to have to get to, using only those values, positive or negative, get to the span of the tightrope. All right. So we'll show you another example for B. If we had 2, 3, and 10, we could use 3 plus 2 plus 2 plus 10. 3 plus 2 would be 5, plus 2 would be 7, plus 10 would be 17. And again, for B, our goal is to get 17 feet. Again, as you've seen in A and B, you can use the values more than once. Or you could go with 2 plus 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 3. That'll equal 17. Or a third one here would be 10 plus 10 plus negative 3. 10 plus 10 would put you at 20. If you add a negative 3, you're going back 3 units. So you'll land at the 17 feet. Remember, they said that the tightrope extends infinitely, so you can go as far forward or as far to the right or left as you wish, as long as you then come back to where he needs to end up. So that's the idea with that problem. All right. Then they want you to think about sort of some more challenging ones. So if you choose to do 235, it is extra credit. All right. If you were given lengths of 2, 5, and 9, could you find these? Could you cross the tightropes when they were these lengths? So again, if you're looking for a challenge, that would be a good opportunity, part A or B, or both. Let's talk about the homework next. So for the homework, 236, it is a review idea problem. You're going to take 54 times 32, and you're going to go ahead and do it with a generic rectangle. All right, so 50 plus 4 on one side, 30 plus 2 on the other. Fill in the parts, write down the number sentence. Same thing with part B. Now, 237 is more related to what we were just talking about for today's lesson. Here you need to find 2 ways to get him across. So if you are going to need to get a total length of 6, and if the numbers you can use are 1, 3, and 4, again, you can use them more than once, and you can use positive or negative, come up with 2 different ways to do that. For part B, using lengths 2, 5, and 7, again, positive or negative, and you can use them multiple times, and you don't have to use all of them, but you need to come up with 2 ways to get a length of 8 feet. For 238, you're going to be simplifying, which means, again, finding the answer. So you're going to be figuring out what these values equal, or what these math expressions, numerical expressions equal. For 239, you're going to, again, complete your incomplete number lines. So you're going to put in the missing numbers on the tick marks. All right. If you look at these, one of the more challenging ones is probably part D, because it goes 0, a tick mark, 10, and then 2 more tick marks. Well, as we've told you before, if you are looking to figure out what those tick marks are, you want to count the number of spaces, which is 3. There's 3 spaces between 0 and 10. So you have to go a total length of 10. Well, 10 divided by 3, of course, is not a really great number. It's a mixed number, or it could be a repeating decimal. So when you do that, you're going to want to keep that in mind, okay? So what you're going to have is 3.3 repeating for your tick mark right above the 0, or 3 1/3 would be fine. And then 6.6 repeating, or 6 2/3. So I'll let you complete that. You still got a couple more tick marks to go, but bear that in mind. It doesn't mean that it can't be solved. It just means there won't be nice whole numbers for you. For 240, one of the topics you're going to review is reading graphs. So what we want to do is to read coordinates. We did some of that last year, but we're reviewing that, which is a great way to make sure we remember those ideas. So when you look at a 4-quadrant graph, which is what this is quadrant 1 in the upper right, quadrant 2, quadrant 3, quadrant 4. All right. If we look at a 4-quadrant graph, and we're told that A is at -3, 5, which it is, how does the -3, 5 tell us where A is located? Okay. How do we know that that's where A is located based on -3, 5? And then they want you to name the coordinates, again in this format, parentheses, number, comma, number, parentheses for point B and point C. And then part C says if we took value or point A and we moved that point 9 units down and 6 units to the right, where will it land? So if we move it exactly 9 units down and 6 units to the right, what would be the new coordinate? For 241, Gracie loves to talk on the phone, but her parents try to limit the amount of time she talks. They decide to keep a record of the number of minutes she spends on the phone each day. So here's your data for the last 9 days. 120 minutes, 60 minutes, 0, 30, 15, 0, 0, 10, and 20. They want you to find the mean and the median. So remember, the mean is the average. You're going to add up the values and divide by the fact that there were 9 values, 9 days worth of data. The median, you're going to put the numbers in order from least to greatest, or greatest to least, and find the middle value. So you're going to find the mean and the median. And then which of those two, mean or median, do you think gives them the most accurate information about her phone use and why? So that is your homework for 2.2.1.